to take a look at congruence and similarity with constructions. Again, we're still building on the compass and straight edge idea and not utilizing some of those other tools students might be more familiar with. So when we're looking to construct parallel lines, this is the process that we're looking at using. Why is this useful? While we don't have the nice chalkboards with the compass and the yardsticks like we used to have, you can still use a Promethean board or even a PowerPoint or a projector to show the actual movements because we're trying to kind of show them these are two congruent angles and it happens in the actual construction process. So when we're constructing congruent angles, we can also construct corresponding angles, which is what helps us create those parallel lines. Same thing with angle bisectors. We can utilize angle bisectors, and we're just trying to really visually show students how you cut an angle in half. So this can be done. GeoGebra actually has some animations you can use, and if you just kind of Google, there's animations you can show your students. So it may not be feasible to have an actual compass in your classroom for every student, but we can still utilize some of these ideas. This would be the steps for constructing perpendicular lines. If I was going to bisect a line segment, this is what I would use. And it's good to kind of show them where these arcs are intersecting or where you're putting the key points. And that happens because the measurements are equivalent there. So here's an example given a triangle, and we want to actually construct an altitude from A. And so if you remember, an altitude is going to be a perpendicular to the line BC. So I would be able to show the construction of this to my students where I'm going to set my compass and I'm going to measure the arc, and then I'm going to utilize the intersecting arcs from B and C to drive that perpendicular home. If I wanted to construct one from this, I'm going to have to do it outside of the triangle because I'm not going to be able to get a right angle inside of the skewed triangle that we have there. Here, I have a right angle already, so I don't need to do anything because AB is already the perpendicular to the triangle. Angle bisectors, it's important to understand that, and if I'm looking at an angle bisector, the length from the bisecting ray to the outer rays, those are going to be congruent. So that's most often what is lost when we don't show the construction side of things. And then as students move further up in geometry, we start naming these relationships, and they don't have the scaffolding to build from because they've not had that construction experience to understand that these lengths are going to be equivalent. And then the angle bisectors of a triangle are not concurrent. They intersect at a single point, and we call that an incenter. And so this is a great vocabulary where we really want to drive it home at those younger levels because they're not using the term incenter as much. And if you notice, it literally looks like it's in the center, hence the idea incenter.